Welcome to Tuesday, October 13th. We're going to continue working today on locating epicenters, part B. It was a little, hopefully it wasn't too confusing. Just 2 pages for us to do today. Our big goal today is determine how far you were away from the center of an earthquake using these seismographs again. So if I'm looking at the simulation, we have this time probe. And we have this P and S wave. So if I hit play, just to review from last week, earthquake happens. P wave hits the station. I hit it about like right when the line. I moved the green one to when the P wave hit. Like right when it starts to get squiggly, when it starts to squiggle, like right there, I'd put it there. And then when the S wave hits, it's always like, and this is afterwards, earthquakes happening. The S wave, I moved the blue one only for the S wave, and that starts the first major line. So the P wave hit at 148 seconds, S wave hit at 259 seconds. The time difference is 111 seconds, and that's going to be important when we fill out our worksheet. So click play. Which one travels the faster, the P or the S wave? Well, I think we noticed the P wave, the purple wave, traveled much faster. So I'm going to say the P wave hit faster. Wait until the seismograph is clear. Turn on the show time probe, which I said show left grab. Use the left green probe to when the P wave hits, and the left and the right one, for the blue one for when the S wave hits. As seen here, P wave hits here. You're going to slide it there. S wave is when the first major jolt is there. What is the time difference? So I'm looking at that as 111 seconds. So let me put another text box there. We have 111 seconds. So predict, how do you think the difference might be between the P wave and the S wave will change as the distance of the epicenter increases? So basically, when we hit reset, then we can move the seismograph. When we get closer, what is going to be the time difference between the P and S wave and we move further back? So if I move it closer, let me just do a quick prediction. Oh, weird. So if I was to slide them, P wave hits here because that's the first jolt, and then the S wave is right here. Notice they're closer together. So I guess there's less time lag, so I would just plain say there is, less time lag between the two waves. There's less time lag between the two waves, the P and the S wave. So, yeah, gather data. Here's what you're going to do is you're going to plot points here. You're going to move it 100 kilometers away from the epicenter and figure out what is the time difference between the lag time, the time difference between the P and the S wave. So how do you do that? You look at this. If you notice, distance from the station from the earthquake, earthquake's here, and I'd probably use a grid here to try to get it exactly 100. So I keep dragging. I'm going to keep dragging until it says 100. 110. There we go. So it says 100. And I would use the grid. So it snaps, clicks 100. You're going to record your data. Boom, boom. Earthquake happens. Wow, that's a really strong earthquake. The first jolt, that's where the P wave was. And then the next major, then the S wave hit. How do I know this? Because then the S wave is always the first major huge spike. The P wave is always when it first starts to jolt. So weird, only 16 seconds, so I would write that in 16 seconds, 16 SEC. And then I'd plot my points to like 100 kilometers here. I'm not sure if I'll be able to do this. Oh, yeah, I can maybe. All right, so 100 kilometers away. It happened at 16 seconds, so I'm going to plot my first point. Okay, 16 would be like right there, if I can write it. Okay, maybe. Yeah, that should work. That, just consider that a point. And then do the same thing again, reset. Now make it 200 kilometers. Boom, it says 200 there. I'm going to click play again. Earthquake happens. Oh, interesting. So I'm going to slide it. The first slight vibration was at here. That was our P wave. And then the next major jolt was right here. So we had 27 seconds. Interesting. We're just looking for the time lag. We're only putting the time lag. So I'm going to slide here. And then, yeah. Draw another point. So at 200, about 27's right here, if it'll let me. 227. If you notice, I'm just plotting points. If I can drop points, maybe. I'll just do this. Make it really small. And then, yeah, I'd say it's about 227. And then same thing here. I would. So if you notice, I'm just plotting points here. Then, I think 16 was like right here. Interesting. Plotting points, we're going to do it for 400, 600, 800, and 1,000. Plot your points. Analyze the graph. Maybe you heard this in math class. Is it a positive relationship, negative relationship? Each side. How does it, when you increase the distance, what happens between the lag time between the P and S wave? Draw conclusions. How does time difference between the P and S wave relate to the distance to epicenter? That's kind of a takeoff. That's very similar to this question up here. As you increase the distance to the epicenter, what happens between the lag time? That's kind of a repeat. This is now using the graph. How does 500 kilometers from the epicenter, what will be the lag time between the P and S waves? So, might want to use the graph here. If it's 500 kilometers, how far is it going to be from the epicenter? Then here, you're going to draw lines like, P waves here, S waves here. So then you have to think about the time and the change in time. The only thing that's tricky about that is, I believe each one of these lines is worth 50 seconds. So I'd say if the P wave hit here, 50, and then the S wave hit here, 50, 100, probably like 105 seconds change in time. Then you're going to use your graph to figure out how far it was from the epicenter. If you don't understand question 8, we're going to review this tomorrow when you come into class. All right, that's my lesson for today. Work on it. Just turn it in. Just turn it in. I'm going to give you credit if you try it, you attempt it. If you don't worry, if you're not right, it's not going to affect your grade. I just want you guys to be able to basically try to get some practice using this P and S waves. We will try it again tomorrow. I hope you can take what we did on Friday. All right, you guys have a good day. Please let me know if you need anything.